Hi everyone. For the final project, I built a few models to predict dengue cases in San Juan and Iquitos, Puerto Rico. I built a negative binomial model, a seasonal ARIMA model, a TBATS model, and a neural network model. I had attempted a Holt-Winters exponential smoothing model. However, I failed at that attempt because I am continuing to forecast at a weekly frequency, and that's too high apparently for that model and technique. I also attempted a seasonal ARIMA with external regressors, but I think I have a bug, so it's not working out so well right now. For the models, there was a lot of EDA. I had to build core plots to identify linear correlations between the independent variables or dependent variable total cases. I also used var select to identify the optimal lag between variables that I thought were correlated well. So that helped inform the features that I would build. They were lagged variables. So with the negative binomial model in San Juan, to forecast San Juan's outbreak, it looks actually not so bad. The troughs seem to fit well. Some of the kind of peaks seem to align for non-epidemic episodes. So that could be fixed, I would believe, with better regressors, external regressors, informing, I guess, um, you know, probably standing water or El Nino effects. I know I had read up on that in some of the articles, but I didn't have a chance to incorporate that. I'll just go through San Juan instead of also going through Iquitos because that's what I built so far. In terms of the seasonal ARIMA, it fits all right in terms of predicting also the peaks. Seems to match the troughs a little bit better, I would assume, just visually. Although it does look quite off for now. I also built a neural network, and this just seemed way off, especially with the short-term forecast that seems to spike with such a magnitude that it doesn't even look appropriate. And then it levels off in the longer term, which also doesn't fit with the actuals. I also tried a TBATS model that was recommended by our textbook author, Rob Heinemann, because it works better with weekly data. Typically, a lot of the dengue models that were built reading through the articles were based on monthly data. So this just thought I'd try something different, and Rob Heinemann recommended it. So this is the result. It's a TBATS model. I'm not quite sure on the interpretation of these parameters, but it doesn't fit very well at all. It just looks like a kind of curve way high and not meeting the troughs of the time series. And this is just a comparison of all three models, the ARIMA, the neural network, and the TBATS. The negative binomial regression is not here because I didn't convert it into a time series, so I couldn't auto plot it. But this actually just shows that the ARIMA of these three performs better. But in fact, the negative binomial has the lowest mean absolute error, and that is likely the model that I'm going to submit to the competition. What I've realized from this exercise in comparison to the midterm is that I thought there was a lot more EDA. Also, working with the time series data at this frequency was not something I had done throughout the coursework or the discussions, where typically I was working with monthly, and I felt that was a lot easier. So it was surprising when the ETS didn't work because I was, forecasting at a different frequency than I was used to. But otherwise, I will continue building my models and fixing hopefully the seasonal ARIMA with external regressors. And that's it for now. So good luck, everyone, and I hope you have a great summer.